Researchers at MIT's Little Devices Lab have developed a set of modular blocks that can be put together in different ways to produce diagnostic devices for various functions, such as infection detection and monitoring. These plug-and-play devices are low-cost, reliable, reusable, and require little expertise to assemble. The components consist of a sheet of paper sandwiched between a plastic or metal block and a plastic cover. The blocks are color-coded by function, making it easier to assemble for various uses. They are about ½ an inch on each side and snap together in different ways. Some of the blocks contain channels for liquid samples to flow straight through. Some have turns and mix multiple reagents together, allowing the user to create diagnostics based on one reaction or a series of reactions. Currently, the system is being used by scientists in other academic labs outside of MIT. The modular, predefined blocks allow the labs to forget about developing the hardware and focus strictly on the biochemistry. Using this system, called ampli blocks, the MIT team is working on devices to detect cancer as well as Zika virus and other infectious diseases. The blocks are inexpensive and they do not require refrigeration or special handling, making them appealing for use in the developing world. Paper diagnostics are usually write one, read once systems. However, ampli blocks can be sterilized and reused for additional reactions without additional hardware costs. The MIT team says their long-term goal is to enable small, low-resources laboratories to generate their own libraries of plug-and-play diagnostics to treat their local patient populations independently. They have already sent them to labs in Chile and Nicaragua, where they have been used to develop devices to monitor tuberculosis treatment and to test for a genetic variant that makes malaria more difficult to treat. The team is now working on tests for human papillomavirus and Lyme disease, among others. Since the ultimate goal is to get the technology into the hands of small labs globally, the researchers are investigating large-scale manufacturing techniques and hope to launch a company soon so they can manufacture and distribute the kits around the world.